Hello, my name is Deepika. In this video, we will take a look on how to run a sample mapreduce program written in Java. We can do this using Hortonworks Sandbox or Cloudera. I will be using Cloudera virtual machine and run in its terminal itself. The prerequisites are to install Cloudera Quickstarts and Java IDE like Eclipse. The mapreduce problem I am considering is regarding Utopia elections. Each vote casted by the citizen will contain one line of contestant name. Every polling booth will have a text file containing all these one line of contestant names. Sample notepad files I have created are in this manner: vote 1, vote 2 and vote 3. They are the specific files related to each polling booth. I first installed a VMware, then downloaded Cloudera, then I downloaded a Hadoop library from Apache site, github.com, Hortonworks tutorials blog HTTP 2.5. I'm using HTTP 2.5, so I have downloaded corresponding Hadoop library 2.7.3 jar file through this download option. Next, I unzip that folder. Now in Eclipse, I have created a new Java project and given the name of the project as Utopia vote count in here. Then through right click properties option, in Java build path, using add external jars option, I have imported all the libraries I want: Hadoop common, Hadoop mapreduce client core, Hadoop mapreduce client job client. Next, I create a new class for the project. It could be done through new class option. The package name I have chosen is Utopia MR. The first class name I have given is vote count mapper. Here first I have imported the libraries with predefined functions and classes I would need. Then the vote count mapper would extend the mapper class. Input is object and text, output is text and int writable. Private would mean that it is visible to objects of same class. Static will mean that there is only one instance of that particular variable. We next assign value 1 of variable 1 as int writable 1. We use predefined function map to take a text value and then split the sentence into words where the spaces occur. All those will be seeded into array of words. Our program will not have any effect with respect to this code, as all the contestant names are taken in one word. Output of the mapper class will contain the first word and the array along with number 1. Next, I have created another class to perform the functionality of the reducer. Here the input comes from the map function of previous class. We pass this input into sort shuffle logic. Here all the key value pairs are collected first and members with same key and are grouped together. Then this will be input to the reduce function. Vote count reducer will be extending the reducer class. Input is text and int writable, which is sequential, and output would be text and int writable. It overrides the reduce function taking input key, which is candidate name, and int writable, which is sequential. If we first initialize vote count to 0 for each candidate, then when each key value occurs, the vote count will be incremented by 1. Then we output the key at the end. Next, we create a vote count application class. The tool interface in here supports the handling of generic command line options. This is standard for a mapreduce program. The tool app should delegate the handling of standard command line options to toolrunner.run. The arguments are combined specific arguments. For this program, we will need a string argument. Its first path would be the set input path and second path would be the output path. The function also sets a job characteristic expecting job output key, which is text, and output value class, which is int writable. It gives the total vote count. It also defines a set mapper class of vote count mapper and reducer class of vote count reducer. Finally, the job gets submitted. Then I have exported the jar file using the export option in here into the bin folder of my project, which is in here. I can see the utopia mr.jar. Now next we need to create the input data for mapreduce program using QWeb interface. So go to the web browser, click on Q, go to the file browser. Using the new directory option, create a new directory Utopia vote count input and upload the notepad files which we have discussed earlier containing the contestant names from each polling booth. Now using Cloudera terminal, we run the yarn command. This is my successful yarn command. It consists of the path where we have the jar file located, then the package name dot class name, then the input file path and output file path. After running this command, go to the view, then click on job browser. You will find utopia mr.jar in success status. This will indicate that the triggering of files with jar file via the terminal has been successful. Finally, the mapreduce program utopia mr is completed. Going back to the file browser, go to the user Cloudera, then user, then Cloudera, go to output file in part. Here we can see the count of each contestant. In this video we have successfully completed the mapreduce program in Hadoop. Thank you for watching the video.